Welcome to today's Explainer. I'm absolutely thrilled to have you here. We're diving right into a massive headache for AI artists and developers, training top-tier models on normal, everyday consumer hardware without having to take out a second mortgage for enterprise gear. If you've been battling to get this stuff running locally, you're in the exact right place. Today, we're looking at the ultimate heavyweight matchup, SDXL versus Flux. But first, we got to talk about the elephant in the room. 12. Yep, 12 gigabytes of VRAM, the dedicated memory on your graphics card. This is the magical, frustrating, and absolutely crucial hardware reality that most of us working from home are bumping up against every single day.
So that brings us to the golden question. Can you actually train modern AI on consumer hardware? We've all been there, right? You curate this absolutely perfect image data set, you hit start, and bam, out-of-memory crash. It is literally the worst. It forces us to figure out how to train these incredibly complex models locally without a massive rig. The short answer? Yes, you totally can. But it takes strategy, precision, and knowing exactly which compromises you're willing to make.
Okay, let's dive into this. Here's our roadmap for surviving the 12 GB limit. We'll look at the overarching dilemma, why SDXL is your reliable choice, why Flux is an absolute experimental beast, break down some hardware VRAM tiers, go over essential optimizer settings, and finally, give you the final verdict.
All right, kicking things off with Section 1, the 12 GB dilemma.
When you look at the source data, the contrast between these two is honestly pretty wild. On the left, you've got SDXL LoRa training. It's comfortable, manageable with a little care, and really the practical go-to for most of us. On the right, Flux. Training a Flux LoRa on 12 gigs is possible, sure, but it's incredibly constrained. You're basically doing a high-wire act with aggressive memory-saving hacks. SDXL just feels like a safe, reliable workhorse for a daily workflow. But full-precision Flux training? The data is crystal clear here. It's simply not realistic on a normal 12G setup.
So, let's jump into Section 2, SDXL, the reliable choice.
If you're rocking a 12GB card, our documentation gives us a proven survival recipe to dodge those VRAM crashes. It's pretty straightforward, so take notes. Lock that batch size strictly to 1. Keep your max resolution at 1024 pixels. You absolutely have to turn gradient checkpointing on. Yes, it trades a tiny bit of compute time, but it saves a massive amount of memory. Make sure you're using memory-efficient attention, like XFormers or SDPA, and definitely keep your buckets enabled. Because the SDXL ecosystem is so mature, this is a highly proven setup. It's exactly where you should start.
The big secret for SDXL on 12 gigs? Discipline. Keep that training loop super lean and skip all the optional bells and whistles that just chew through your VRAM. If your main goal is to iterate fast and comfortably to get the perfect artistic output, this lean setup is hands down the winner.
Moving right along to Section 3, Flux, the experimental beast.
Now, what's really interesting about this slide is the sheer mind-boggling scale we're dealing with. Flux uses a massive transformer-based architecture. We're talking about 12 billion parameters. And out of the box, it wants roughly 24 gigabytes of VRAM in standard full FP16 precision. Just let that sink in for a second. It wants 24 gigs, and we only have 12. That resource gap is huge, meaning we have to completely change our approach to the training pipeline.
So, how do we force a 24 gigabyte giant into a 12 gigabyte box? With extremely aggressive configs. Full FP16 is out the window. You have to drop down to FP8 base or FP8 base unit, basically squishing those numerical weights down to 8 bits to save space. Caching your latents and text encoders? That's not just a friendly tip. It's practically mandatory for basic survival. You're also going to need to drop your resolution to a 768 pixel max to start, and naturally, gradient checkpointing stays on. You literally need all of these just to get Flux to boot. But I need to be perfectly clear here, because the sources really emphasize this. These configs make Flux possible on 12 gigs, not fast. If you go the Flux route here, you have to accept that high-speed training is off the table. Expect slower training, sluggish iterations, and spending way more time tweaking your memory footprint just to get the thing to run at all.
Let's zoom out a bit for Section 4, Hardware VRAM Tiers Explained.
And this brilliantly illustrates exactly where we stand in the broader hardware ecosystem. Down at 8 gigabytes, you are in pure survival mode. SDXL needs heavy optimization, and Flux is practically impossible. Then we hit our focus today, 12 gigabytes. the ultimate budget sweet spot. It's comfortable for SDXL, but just barely on the usable edge for Flux with those heavy tricks we just talked about. Once you jump to 16 gigabytes, Flux actually starts feeling good and reasonable. And 24 gigabytes or more, that's the recommended territory where serious Flux training really shines.
All right, Section 5, Essential Optimizer Settings. Let's look at the technical cheat sheet. For SDXL on 12 GB, stability is everything. For your optimizer, choose AtomW 8-bit if you want to keep things simple, or Adafactor if you're using advanced workflows with a fused backward pass to squeeze out a tiny bit more memory. A rock-solid baseline is setting your network_dim to 32 and network_alpha to 16. Then, dial in your learning rate right at 1E-4. Pair that with BF16 or FP16 depending on your GPU, and you are good to go.
Now flip over to Flux, and things get a lot more sensitive. When VRAM is this tight, our sources emphasize that Adafactor is an absolute lifesaver. Because of its fused backward pass memory savings, you can still use AtomW 8-bit, but Adafactor is the star here. Notice how we drop the dimension down too. Keep your network_dim somewhere between 16 and 32, with your alpha at 16. You'll also want to lower that learning rate a bit, to around 5e⁻5 or 1e⁻4. This is your ultimate survival configuration.
And finally, Section 6, the final verdict.
I absolutely love this direct quote from the source data, and I think it completely hits the nail on the head. If your goal is reliable home training, use SDXL. Treat Flux as an advanced optimization project. That really is the whole shebang. For sanity, predictability, and the speed to actually finish your art, stick to SDXL. If you want to push the bleeding edge and are totally fine with treating the training process itself like a giant puzzle to solve, then cautiously step into the Flux zone.
So what does this all mean for you? It leaves us with one massive question to wrap up this explainer. Look at your own workflow right now. Are you optimizing for speed today so you can just create? Or are you experimenting for tomorrow, testing the absolute boundaries of your hardware? Your answer to that is going to dictate exactly what you fire up next. Thank you so much for hanging out with me today to break this down, and happy training.